Wonderful. All right. So I just wanted to start the lecture here and the recording with some updates. For next week, we will have a lecture doing a review for the final exam on Monday, Tuesday, and Wednesday of next week. So we will not have a Saturday session or a Friday session. We're moving them to the beginning of the week. So that way, if you're taking your exam on Wednesday, you can go to either Monday or Tuesday session. So be on the lookout for those emails about the time changes on those. Mine is going to be Tuesday morning. Mine's going to be Tuesday morning. So if you want to come to my review session, it'll be Tuesday morning. And the way we've done it is each review session, we're going to be doing different problem types. So on Monday, we're going to do different problem types than we do on Tuesday. And then Tuesday, we'll cover different problem types than Wednesday. So what we're trying to do with the lecture is cover as many problem types that are going to be on your exam as possible. So in order to do that, we're going to differentiate. So if your exam is until Thursday and you want to go to all 3 sessions, or if you want to watch the recordings, strongly suggest doing that because they are extremely helpful when preparing for the exams. All right. If you have any questions on that, please let me know. You can use the chat box. Instead of to everyone, we can just put to Paul and nothing will be on the recording. But I'll also stop the recording from time to time and see if there are any student questions on the ones we're working on. I think my session, I believe, is either 9 or 9:30 on Tuesday morning. And that may be Eastern time. Actually, I don't think it's Eastern time. I think it's Central time, which means it'll probably be 10 to 11. 10 to 11 Eastern, 9 to 10 Central. I think so. I'll double check this. I was looking through my email and I was trying to find the times that we had agreed upon, and I couldn't find it like immediately. So let me see. I should just be able to find it real quick. All right, I'm only going to take one more minute to check. You know what? Actually, that's right.
Paul, I know on Tuesday it's from 10 to 11.
Okay, perfect. It is 10 to 11.
I checked the email for Monday. Was it Monday and Tuesday?
Yeah, Monday, Debbie Yaus is doing the one on Monday, but it is 10 to 11. That's Eastern time. And I know most people are on Eastern time. I'm on Central time.
Yes, and I'll pull up the email to get the Monday time.
Okay, great. Rika, thank you so much. I was searching through there. Perfect. So, but Tish, the recording's also going to be available. So you can also watch that recording. And they usually come up right after. So great question. Others, and thank you, Rika. Thank you so much. All right, let's go ahead and get started. So we're going to start on this one. This was homework. And I'm doing 07B. This is 07B. We work our way backwards. This is number 9. Okay, it says, what rate of interest compounded annually? So that's very important that it's compounded annually, because we have a formula here that we're going to use, right? It's the after equals before times 1 plus r divided by n to the nt power. Okay, and n is how often we are compounded. It's how often that it's compounded. All right, and there's a little n table that we can make fairly quickly. Rika, thank you so much. Thank you. So if you look in the chat, all the times are there. It's Monday from 2 to 3 p.m. Eastern, Tuesday from 10 to 11 Eastern, and then Wednesday from 6 to 7 Eastern. If you can't make those times, or if you have questions, I'm also going to post my office hours and my link to my office hours you're more than welcome to come to any of my office hours. They're always open to all students. So I will post that in the chat as well. Okay, so that way it won't be a lecture format. It'll just be you can come in and ask questions, or if you want to work on review and if you have questions, I can answer them. So thank you so much. All right, back to the problem. We have the formula for compound interest. This is the formula for compound interest. The variables don't matter, right? You may have something different. A equals P, and P stands for the principal. So how often it's compounded? If N is 1, if it says annually. So annually means N is 1. N is 2 would be semi-annually. All right. And then N is 4 is going to be quarterly. All right. And then the last one you'll probably see is N is 12 would be monthly. All right. And you're always going to use a different formula. If it says continuously, or continuously. If it says continuously, that's A equals B times E to the RT power, E to the RT power. So you use a different formula. So this one, we are not using the continuously formula, obviously. We are just using the compound interest formula. Now, this question gives you very little information. So it tells us what N is because it says annually. We're going to use N as 1. Okay. And the only other bit of information they give us is the time. The time is 6 years. So we know that T is 6. In the question, though, it says is required to double. Okay. They don't give us how much we have before. But we know the after is 2 times the before. The after is going to be 2 times the before. It's totally up to you. For me, I probably would rather just say, well, even though the problem doesn't say it, I'm just going to say my before is $1,000. If my before is 1,000, to double it would be 2,000. Okay. If you're more algebra-y, you might just want to say 2B equals B times 1 plus R. We know R. No, we don't know R, so we put R. We know N. N is 1 to the N, which was 1, times T power. Okay. This is probably, if you're like super like algebra and you like being a perfectionist in terms of algebra, this is what you write. I would just say before is 1,000 and then multiply before times 2 to get the after. So here I'm just going to copy paste. We're just going to move this information over. Oh, sorry about that. Hit the wrong. There we go. We're just going to copy paste this down so we can clean up all the notes and just work on the problem. All right. So here we go. We're just going to put 2,000 equals 1,000 times 1 plus R. We don't know R. That's what we're looking for. R is divided by 1 raised to the N, which is 1 times T. T was 6 in this case because the time was 6. It says 6 years. So we're solving for R. We got to get the R by itself. Well, the first thing we want to do to clean this up is to get this exponential by itself. So we're going to divide both sides by 1,000. So we get 2 equals, the 1,000 cancels, 2,000 divided by 1,000 is 2. 1 plus, well, it's just 1 plus R, right? It's 1 plus R because R divided by 1 is just R to the 6th power. Okay. You can solve this problem. In fact, you solve this problem without using exponentials or logarithms, right? Which is kind of weird that it's in the exponentials and logarithms section. So we're going to take the 6th root on both sides. We're going to take the 6th root on both sides. Why do we take the 6th root? Because the 6th root cancels a exponent of 6. And this is where in your calculator, okay, so when you bring up your calculator, all right, you are going to have a button potentially. So how do we calculate this in our calculator is the question. We're going to enter the number 2. And then there are 2 different ways to do it. You could enter, if you have a button that has a root power with an N root power, you hit that button. You may not have that button, okay? And that's okay. So if you have that button, do that. So it'll be 2, and then this button, and then 6, and then equals will get you the 6th root of 2. Let's do that in our calculators right now. And I get 1.1. Get rid of it. There we go. 1.12246. Okay. Okay, yeah. We're going to talk about what if we don't have that button just a second. So this was equal to, so it's going to be 1.12246 equals, what were we left with on the right side? We were left with 1 plus r. So that's going to be 1 plus r. Then we subtract the 1 on both sides. So our r is going to be equal to 0.12246. And this problem says, and we can jump right back to it. This problem says round to 2 decimal places. So it needs to be a percentage. So we need to make sure it's a percentage. To change a decimal to a percent, multiply by 100. And then we're rounding to 2, or you can move the decimal place to the right too. So it's going to be 12.246. We need 2 decimal places. So we go back to the 6, or sorry, we look at the 4, but the 4 goes back 1 to the 6. 6 is bigger than 5, so you round up. So it's going to be 12.25. Okay. So the other thing that you can do to do a root power. So this is one way to do the root power. The other way to do a root power is 2, and then the button that you have is probably an X to the Y button. You may also see a Y to the X button. So use an exponent instead. And if you use an exponent, you want to put parentheses and 1 divided by 6. And this property does come up, that a root power is division in an exponent. So what we're using here is that the root power is division in an exponent. Oh, yes. Oh, okay, perfect. That also is the correct button. You may have an X to the blank box button. That one will work. Yeah. All right, I'm actually going to pause here and let's so all I'm going to do is enter this answer into my math lab. So when we go to my math lab right here, we're just going to put in the 12.25. Here it is right here. Uh-oh, is it getting upset? Oh, it changed the, wait, did it just change the problem on me? No, we're fine. It accidentally had you an example. So it was 12.25. There we go. All right. So question number 9 is one of the questions that I wanted to go over today. These are handpicked. The next one is question 13. Next one is question 13. This one does say compounded continuously. So we're going to use a different formula when it says compounded continuously. So we're going to copy paste this problem over. And get back to our whiteboard. Here we go. All right, now what's happening? Oh, okay. Wait, where'd the whiteboard go? Here it is. We should get, yep, we see it now. All right, perfect. All right, so we are going to just make some space here. There we go. Okay, so let's paste this problem in and we'll get started. All right, so it says, how many years will it take for an initial investment, right? So, well, let's read the whole thing through. An initial investment of $40,000 to grow to $60,000. Assume a rate of interest of 20% compounded continuously. So we're compounding continuously. So let's see. So hold on. It's going to, I think this is fine. Is it fine? Everything's probably fine. The formula sheets, let's see. So let me go to, here we go. I have the, I'm actually not teaching a Math 136 online, so I have it in my sandbox, I think. So I'll bring up the formula sheet and we can see what that formula sheet looks like. So if we go to the modules and the formula sheet provided in the modules, yeah, and then it should be in module 8. Module 8, the formula sheet, or is it at the top? It might be at the top. Do not publish, resources. Let's look for the, I saw it somewhere. Is it in the, it might be actually right here. No. And I know it's under modules somewhere. Sorry, just because I'm not teaching it. And actually I haven't taught this course in an extremely long time. At least not the online version. So there is a formula sheet, I guarantee it. We're just going to look through all of module 4 because I'm sure it's got to be there somewhere. And it is helpful knowledge to know what you have on the right on the exam. And that way I should be using exactly the same formulas that they use. Scan. That's homework. That's more homework. That's a practice test. It's under resources, not under modules, or it's under the resource module. Gotcha.
I think I got this working. The last time that we found last time I found the formula sheet for the midterm, it was under, I think 4, you had to go to module 4. And then there was like I don't know if that's the same formula sheet you're looking for or not.
Here
but
it is.
The one that they gave us for the midterm, I think you go to module 4 and then you'll see like prep, and I believe there's a resource. I don't know, but I do know that it's under module 4 is where I printed that formula sheet. I just curious, is that the same one? If that's the same one, I've still got it from the midterm.
Yep, it's the same exact one. And then we see the continuous interest formula right here.
Okay.
It's A equals P. They like to use P instead of B. So P stands for principal. B for me stands for what you have before you started. So yeah, Tish, it's the same formula sheet.
Awesome.
And I'll go ahead and use that same formula, the A equals P times E to the RT that they use. Yeah, thank you so much, Tish. It was under the course resources.
All right, thanks. But it will be that same formula sheet. It's just the second half of those formulas, not the first half, right?
Exactly right.
Okay.
And
okay,
so
gotcha.
Let me get back to the formula sheet real. I am back to the formula sheet, but I think my internet might be going a little bit slow right now because I'm not seeing the formula sheet up on the screen right now. I wonder why not, actually. There we go. So you do, and this is a helpful hint for the midterm exam. You will have to use the quadratic formula on the final exam. You will have to use it. So you will potentially, well, if you don't have it memorized, you'll have to use it for that. The uniform motion formula, you're not going to use the working together. You're not going to use the simple interest, and everything below simple interest, you will use. Okay, potentially. Maybe you won't use the product and the quotient rule, but you'll use one or the other. All right. Great question. Great comment. I'm glad we saw this, and I'm going to use the A equals P as well. So now let's see if this pops up. It does. Perfect. So we're going to use the formula A equals P times E to the RT. And the after we want to be 60,000. So that's going to be our after. We started with our principal was 40,000. 1, 2, 3. Yeah, we need one more times E. We don't know the interest rate. So we do know the interest rate. I lied, right? The interest rate is 20%. So if it's 20%, you have to change the percent to a decimal by dividing by 100. So that's going to be 0.2. So 0.2, and we want to know the time. How long is this going to take? Okay. To solve an exponential, in order to solve an exponential, we have to get the exponential by itself, divide by the 40,000 on both sides. So we get 1.5 is equal to, those cancel, and you just do this in your calculator, right? 60,000 divided by 40,000, you get 1.5. E to the 0.2 times T. Anytime the E is all by itself and you want to get rid of it, you put a natural logarithm on both sides. The reason why you do that is the natural logarithm and a base of E are inverse functions. They then cancel each other. So on the left side, you still have the natural log of 1.5. On the right side, you're just left with 0.2 T. So now we're going to divide both sides of the equation by 0.2. And this is what we need to do in our calculator, because on the right side, the 0.2 cancels. We're just left with T. So T is equal to. The way we do this in our calculators is, let's see. Most calculators will just have an LN button. So you hit the LN button. And then so these are the buttons. If these are the buttons on top, this is what the display looks like. It'll look like LN, and it puts a parenthesis in for you. So you'll have to put in the 1.5, and then you'll have to end the parenthesis. So then it'll look like 1.5 end parenthesis. And then you'll have to hit divided by, and then 0.2. So then it'll look like, depending on your calculator, it may create a fraction and then put 0.2 at the bottom, or it just may put like a division sign like the one that you put. And then when you hit equals, we want to find the answer to this. So we're doing the natural log of 1.5 divided by 0.2. It's only going to take 2 years. So this is going to be equal to, T is going to be equal to 2.0273. And on this problem, it says round to 2 decimal places. So we look at, well, the 2 is where we want to round to. So we look 1 behind it. We look at the 7. 7 is 5 or bigger. So this is going to round up. 2.03 will be our answer for this one. Okay, I'm going to pause the recording here, but we're going to finish it up. I just want to make sure.
Came out okay.
All right, excellent. So we're going to pop back to the homework problem, and we're just going to put in our answer of 2.03. 2.03 years. That's because your interest rate is so high. 2.03 doesn't take very long to double your money when it's compounding continuously, and you have a high interest rate. All right, next one on my list is 21. 21 is actually one of my favorite questions, I think. One of my favorite. So I'm going to go ahead and, oh no, I almost, okay, hold on. I'm going to copy paste this problem over. Here we go. And we'll get started, except we can't super see it. I'm going to rewrite it anyway. All right, but that's okay. Here we go. All right. So it's my favorite problem because we run into a problem like this every single spring. We have a problem like this that happens every single spring, right? We're always happy when the weather turns nice and there's no mosquitoes. And then spring comes along, late spring, and we see 1 or 2 mosquitoes, and then we see 500 mosquitoes, and then we have mosquitoes all summer. So on this one, it says the size P of a certain insect population at time T obeys the function P of T, which means the population of mosquitoes at time T is equal to 900 times e to the 0.08 T. Okay, so we want to know the determine the number of insects at time equals T. So this is a question purely about understanding the equation. Okay, you also could just put in 0. That's fine. So you could look at it both ways. I'll look at it from a formula perspective first. P of T is the population in T days. 900 is your initial population. Okay. This is your growth rate. That's R. That's your growth rate. And then T is just your time. Okay, so that's our formula. If you wanted to, for this first part, what is the number of insects at 0 days? That's P of 0. What's P of 0? That's going to be equal to 900 times e to the 0.08 times 0. Well, 0.08 times 0 is 0. So that will be 0. E to the 0 is 1. You get 900 times 1. So our answer here is 900. Okay, you can get that just by looking at the formula. All right, and we're gonna walk through this in my math lab just like we walked through our homework. So we're gonna do 900 for the number of insects. That's how many we started with. All right, what is the growth rate as a percentage? So it wants this number as a percentage. The growth rate is, well, part B is about the growth rate. So the growth rate is 0.08, and we can change that to a percentage. So multiply it by 100, it becomes 8%. I think many of you are probably just moving the decimal place to the right too. That's absolutely fine. Part B's question, what is the growth rate, right? B asks for the growth rate as a percentage. So the answer is 8, and that has a percent sign on the side. So we're going to show that. We're just going to enter that answer in my math lab right now. So we have, what is the growth rate? And we know they want it as a percentage because it says percent. We put 8. All right, excellent. Now, what is the population after 10 days? Okay, so it's only been 10 days. So what is the population? So part C wants the population at time equals 10. Okay, and actually, I just realized we're gonna, there's nothing much we can do. Never mind. We're okay. We're just gonna scroll up instead of down. We'll get rid of some of this. There we go. We'll get rid of the explanation behind that so we can just find. All right, so we're going to find the population at T equals 10. So it's going to be P of 10 is equal to 900 times e to the 0.08 times 10. There's no solving to do here because the P is already by itself. The P is already by itself. All we need to do is use a calculator. So it's going to be 900 times E. And in fact, you know what? I think most students will just do this all at once in their calculator. Okay, so let's do it all at once on our calculator. The first thing you're going to have to put is 900. Then you just put your multiplication sign. And then you're going to have to hit the second button and then the natural log button. So what's it going to look like? Is this going to put 900 times, and then second ln is going to give you e caret parenthesis. This is the display. This up here is what these are your buttons. Those are the buttons that you press. Then we're going to have to put in 0.08, and then we hit times again, 10, and you're going to have to end the parenthesis. So then it's going to look like 0.08 times 10, and it ends the parenthesis. That's what you want the display to look like. Those are the buttons that you're going to press. I'm going to go ahead and do that in my calculator. So that way we have an answer. And then we can make sure that you're all doing it in your calculators correctly. You don't need an E to the caret button. The way you do it is it's going to be a second, or maybe it's going to say shift. It might say shift. So if you have a shift button, it might be shift instead of a second button. Typically on a calculator, that second button is in the top left of the buttons.
Is it the IN button that I shift before I push?
So you'll hit shift,
Uh-huh.
and then you'll hit the LN. It's actually an L, even though I know it looks like a capital I. It's an L for logarithm, but yeah.
Oh, okay, I got it. Thank you.
All right, perfect. Great question. All right, let's see. Okay, then I got to multiply by. So what we should get when we're all done is 2002.9868. All right, let me double check that I did that correctly in the calculator also. No, wait. No, I messed up. Don't look at mine. That's wrong. We'll pretend like it didn't happen. That's wrong. I put in the wrong number. I put in just 0.8, not 0.8. I should have put in. Oh, no. Everything was fine. That's fine. Guys, everything's fine. Right? I put in 0.8, which is fine. Everything's fine. That's exactly what you should get. Let's pause it here, make sure we can get that. This one says round your answer to the nearest whole number. That's to one to the left of the decimal point. So we have to look back one, because that's a 9. It's going to bump our 2 up to a 3. So for our answer, it's going to be 2003 mosquitoes. We're going to go ahead and answer that because there was a little bit of hesitation on my part to see if it was right or not. I'm almost positive I did it correctly. And then that way we can make sure that everyone is doing it in their calculators correctly as well. All right, there we go. So I'm going to pause the recording here before we get started with part D. So let's pause here.